suppose velocity. For example, velocity. So velocity means basically meter per second. So I have given about the fundamental quantities. In fundamental quantities, meter is basically represented by L and second is represented by T. So it will be L T to the power minus 1. So this is the dimension of velocity. So when we are talking about the universal gravitational constant, universal gravitational constant, universal gravitational constant. So basically it is represented by capital Z. Already you know this formula, F is equal to G m1 m2 divided by r square. So we have to find the dimension of universal gravitational constant. Why it is called universal gravitational constant, this Z? Because the value of capital Z is remains same in the universe. So that is why Z, it is known as capital Z, it is known as universal gravitational constant. Now see, capital Z is equal to, we can write Fr square m1 and m2. So this is the basic formula, and from the given formula we can find the dimension. Now see force. Force means F is equal to ma. We can write ma, and here r square. So m1, m2 like this. So m means mass. Mass basically represented by capital M, and here acceleration. Acceleration is given. So you know the unit of acceleration is meter per second square. So meter basically represented by L. Here second square like this, meter per second square. And here distance also represented by meter. So it will be meter square divided by mass is given here. So capital M here, capital M. So this mass cancel. So we can write here L cube divided by m t to the power square. So finally we can write m to the power minus 1 L cube t to the power minus 2. So this is the dimension of universal gravitational constant. So how we will do? F is equal to ma. A means F is equal to m means mass, A means meter per second square, and here you can see distance means L square. So here mass m1 represented by m, mass m2 represented by capital M. So one mass cancel. So finally we can write L into L square, that means L cube. T will come down, it will come down. So it will be T square. So finally we can write m to the power minus 1, L to the power 3, and T to the power minus 2. So this is the dimension of universal gravitational constant. You always remember F r square divided by m1. This one formula. So this is the process. This is the system. In this way you can easily find the dimension of any quantities. That is why it is called general dimension. For example, you can see this is one question I am discussing from your CEE exam, BSc nursing course. One question is given in 2024. You can see dimension of Stephen constants. Dimension of Stephen's constant. Dimension of Stephen constant. So what is the dimension of Stephen constant? So it is basically related with your thermodynamics. So the formula is E is equal to sigma T to the power 4. This is the formula. Now we have to calculate the dimension of sigma. Sigma is called Stephen constant, and here E is the energy and T means here temperature. This is called absolute temperature. Temperature basically represented by Kelvin. So in this case solution, you can see dimension of sigma is equal to E divided by T to the power 4. So dear students, you remember energy. So in this case you can use mgh. In this case you can use half mv square. In this case you can use force into displacement. So a lot of formulas are there, so you can use any one. So I am considering mgh divided by Kelvin, Kelvin to the power 4. Now here m means mass, g means meter per second square, and height means meter L, and here k to the power 4. So this term we can write in this way: ml square t to the power minus 2, and here k to the power minus 4. So this is the dimension of Stephen's constant. So in this process we can easily calculate the dimension. So this is the dimension or general dimensions. So I told you that there are three types of dimension. One is general dimension, other is equation form dimension. So now I am going to discuss equation form dimension. So equation form dimension, you can see number 2, equation form dimension. Equation form dimension. Equation number 2, equation form dimension. Suppose one equation is given to you. So from the given equations, how we can calculate the dimension? So you remember, in case of equation form dimension, if it is given in the form of equations, then at the time you have to remember one principle. The name of the principle is principle of homogeneity. So principle of homogeneity means, suppose one equation is given, suppose y is equal to x square plus 2. This is a kind of equation is given. So you remember, dimension of left side quantity is equal to dimension of right side quantity. So this is called principle of homogeneity. You always remember principle of homogeneity. Using this principle of homogeneity, we can find the equation form dimension. For example, you can see, suppose one question, example 1. Suppose you are going to find, suppose you are given x is equal to a plus b, x is equal to a plus bt plus ct square. So this is a kind of relation, this is a kind of equation is given to you, and here you remember x is a distance, it is represented by distance, and a, b and c constant, and t time. So when we are talking about the x is equal to a plus bt plus ct square, at the time we have to use homogeneity principle. So now here you can see, according to principle of homogeneity, this equation can be written as, how we can write, x is equal to a first. But according to mass rule, we cannot write. But according to principle of homogeneity, in terms of dimension, we can write like this: x is equal to a, again x is equal to bt, again x is equal to ct square, like this. So in this way, we can write the formula, write the equations. So now we have to calculate the value of, find the dimension of a, b and c. Suppose what is the questions from the given formula we are going to find the, so suppose a into b divided by c we have to calculate. Find the dimension of a cross b divided by c. So first a means x means distance means l. So the value of a is l. Again b is equal to x by t. X means meter means l, time t. So l t to the power minus 1. So this is the dimension. Again c, you can see here, c we can write x by t square. That means l t to the power minus 2 we can write like this. So therefore this is the dimension of a, b and c. But according to our questions, we have to calculate the dimension of a cross b divided by c. So therefore you remember a cross b divided by c is equal to a cross b. That means the first a, what is the value of a? L, dimension L, multiply, what is the value of b? Here given L t to the power minus 1. And what is the dimension of c? You can observe this part. C means L t to the power minus 2. So the first term we can write L square t to the power minus L square t to the minus 1, and here L t to the power minus 2. So this part we can write L, 1 L cancel L, and here t, here t. So dimension of A cross B divided by C, A cross B divided by C is equal to LT. So A cross B divided by C is equal to LT. So this is the dimension of A cross B divided by C. So this is a kind of equation form is given. So from the equation we can easily calculate the value of dimension of A, B, C. So another example you can see, suppose you have given this is a, you have given one more example. You can see, suppose P is equal to A minus T square divided by Bx. You see, this is a kind of equation. So from the given equations, find the dimension of A divided by B. Find the dimension of A divided by B. So first you have to calculate the dimension of A, after that dimension of B, after that A by B, you just take the ratio, then you will get the final result. Now solution, you can see here P is equal to A minus T square divided by Vx. So this can be written as P is equal to A minus T square divided by Vx, like this. So P is equal to A minus T square. Here you remember P means pressure. P means here given pressure. P means pressure. And T time. T is time. And already you know A and B are basically constant. So in this case, this formula we can write, these equations we can write, Pbx is equal to A minus T square. So this is a kind of equation given to you. From the given equations, we have to calculate the value of A and B in terms of dimension. So according to homogeneity principle, of homogeneity, we can write Pbx is equal to A. Again we can write Pbx is equal to A. Again we can write Pbx is equal to T square. Again we can write A is equal to T square. So according to mathematics rules, we cannot write this term like this. According to principle of homogeneity, we can easily write like this. So in this case, first you see I am going to find this, but easily we can calculate the dimension of A. So I will prefer this relation. So A is equal to T square. A is equal to T square. So this is a dimension of A. Now what is the dimension of B? Dimension of B means B is equal to T square divided by Px. So P means pressure. You remember P means pressure. So we can write dimension here. P means pressure. Pressure means F by area. So area I write here. F by area. So force is here X. So in this case you can see here T square. Area means meter square. So meter square means L square divided by force. Force means M. M-E. A means meter per second square into L. So this term we can write L square, here L cancel. So now we can write M to the power minus 1 and here T to the power 4. T to the power 4. So this is the value of B. Now therefore A by B, A means T square, B means M to the power minus 1, T to the power 4. So this can be written as like this, M T to the power minus 2. So this is the dimension. So this is the process. That means we can find the dimension easily from the given equation form. This is the process. I think you got the idea how to calculate the dimension. So next example you can see. Suppose we have given F is equal to, suppose this is a question, this equation, suppose f is equal to, it is given a x square minus bx, it is given to you. So here f is a force, here f means force, here force. I am not writing the questions in the full form, because in shortcut I am writing. So f is equal to force and x is a distance, and a b are basically constant. So now from the given relation, how we can calculate the value of a and b? That means dimension of a and dimension of b we have to calculate. Now you can see solution. So f is equal to ax square minus bx. This is the relation we have given. So according to principle of homogeneity, but according to principle of mathematics we cannot write, but according to principle of homogeneity we can write f is equal to ax square, f is equal to bx. Again we can write ax square is equal to bx. So according to principle of homogeneity, we can easily write f is equal to ax square, f is equal to bx, ax square is equal to bx. Now here directly we can write, if we use this part, a by b, we can write x by x square. So it will be x. So a by b, suppose a by b we are going to find. So a by b, so a by b is equal to question mark. So a by b will be 1 by x means distance, meter is L. So L to the power minus 1. So in simple calculations, so because you see according to our questions we have to calculate a by b only. So from this relation directly we can find the value of a by b. But if we want to do this one, it will take some time. So it is easy to take these relations to calculate the value of a by b. So this is over. Next you can see these questions, slight tough question. That means it is also related to maths. Suppose using dimension find the value of x. Suppose you have given, very important question this one, CEE questions. So integration here given, and here you can see time is given dt under root twice at minus t square, and here a to the power x sine inverse, here t by a minus 1 it is given. So this is a kind of relation is given to you. So from the given relations we have to, using dimension we have to find the value of x. That means find the dimension, find the value of x using dimension. Find the value of x using dimension. So you can see the relations, but it is looking a very tough question, but very simple. But only just here mentioned, they have mentioned integrations. So there is no rule of integration in this relation. So first you see solution. So suppose it is given. Here first you have to check. This is a kind of relation. So in which part we can use principle of homogeneity? Now see, this part we can use principle of homogeneity. So using principle of homogeneity we can write t by a is equal to 1 according to principle of homogeneity. So a is equal to t. A is equal to t. Now see, using this dimension here, so integration is nothing. This is a kind of confusion. So dt means it will a kind of time t, and here twice a means t, and here t and t minus t square is equal to, it will be a to the power x. Now you remember, when you put the value of t instead of t a by a, that means we can write like this, using a by a minus 1. So this term will be dimensionless. Dimensionless quantity. So that is why this term will be neglected. Now implies t here twice t square minus t square, it will be t. So it will be like this, t square, and here a to the power x. So square root cancel, it will be t is equal to divided by t is equal to a to the power x. That means a to the power x is equal to 1. But our aim to calculate the value of x, so that is why we can write a to the power x is equal to a to the power 0. So a cancel, x is equal to 0. So this is the dimension of, using dimension we can easily calculate the value of x. So this is a kind of process. So in this way we can easily calculate. Now one more numericals I am going to discuss. It is also related equation from dimension. Now see, one more example. Suppose p plus a by b square, and here b minus b is equal to rt. So you remember, this is a kind of equations, this is a kind of relations, you remember, and name of the relation is van der Waals equations. So van der Waals equations, it is the modification for of PV is equal to RT. That means ideal gas equations. After modification of ideal gas equations, it is given like this. So PV is equal to RT for 1 mole gas, and PV is equal to nRT for n mole gas. So this is the modification form of ideal gas equation. Now see, from the given relation, find the dimension of a by b. Find the dimension of a by b from the given relation. So here already you know, P means pressure, V means volume, and R is a universal gas constant, and T means absolute temperature, and A and B will be the constant. Now see solution. So this relation is given to E. So according to principle of homogeneity, we can write P is equal to A by B square first, and again we can write B is equal to B, and we can also write P plus A by B square is equal to RT. We can also write V minus B is equal to RT, but no need, because we have to calculate the A by B. So from these two relations we can easily get the value of A by B. So now B is a volume. So volume means L cube. So here A means PB square. A means PB square. P means here pressure. Pressure means F by area. Volume means L cube whole square. So now see, F means ME. A means meter per second square divided by L square into L to the power 6. So now you can see M L to the power 7 T to the power minus 2 whole divided by L square. So we can write M L to the power 5 T to the power minus 2. So this is the dimension of E. So according to our questions, we have to find the dimension of A by B. So A by B means, what is the value of A? A means here you got M L to the power 5 T to the power minus 2 divided by B. B means L cube. So M L square T to the power minus 2. So this is the dimension. So dear students, you can easily calculate the value of any dimension related with the equations, related with the formula, you can easily find out. So last, third number, I told you that there are 3 types of dimensions. So third number will be equating form dimension. Equating form dimension, you can see what is the meaning of equating form dimension. Number third, equating form dimension. Equating form dimension. So equating form dimension, suppose you have given F is equal to 6 pi R B eta. This is a kind of formula, and this formula basically it is called Stokes law. So here given alpha, here given beta, and here given gamma. So using dimension, we have to calculate the value of alpha, beta, and gamma. Using dimension, we can calculate the value of alpha, beta, and gamma. So equating form, this is equating form dimension. So using dimension, this is the question. If F is equal to this one, using dimension find the value of alpha, beta and gamma. So using dimension find the value of alpha, beta and gamma. So you can see solution here. So we can write, so f is equal to 6 pi r b eta, alpha, beta and gamma. So f is equal to 6 pi r b eta. So here you can see f means me, a means meter per second square. So dimension of any constant term is always 1. So there is no dimension, so it will be 1. R means distance, distance means meter, meter means alpha. And here velocity, velocity means meter per second, meter per second it will be meter. And this is the eta, eta means coefficient of viscosity. The dimension of coefficient of viscosity m l to the power minus 1 t to the power minus 1, m l to the power minus 1 t to the power minus 1. So here given gamma, gamma is here. So now rewrite m l t to the power minus 2 is equal to, here we can write alpha, and here we can write plus beta, and here we can write minus gamma. So now here t to the power minus beta and t to the power minus gamma, and here m to the power gamma only. Now see, comparing both sides, we will get m to the power 1, m to the power gamma, this part and this part. So m will cancel, so gamma is equal to 1. Similarly here t to the power minus 2 is equal to t to the power minus beta plus gamma, we can write. So t cancel, minus 1 cancel, beta plus gamma is equal to 2. So gamma value is given 1, so beta plus 1 is equal to 2, beta is equal to 1. And third number you can see here, alpha, l is equal to alpha plus beta minus gamma is equal to l to the power 1. 1 is given here. So l and cancel, so alpha plus beta minus gamma is equal to 1. So value of alpha, value of beta already you know 1, gamma also 1 is equal to 1. So alpha is equal to 1. So using dimension we can easily calculate the value of alpha, beta and gamma. So this is a kind of process. In this process we can easily calculate the dimension. This is a equating from dimensions. So dear students, you remember I have discussed today about the errors and dimensions unit. So basically in this chapter you remember about the errors, whatever formulas I have given, you just memorize, check it and practice it. Thank you so much.